Alright, Raspberry Pi Pico 2W came. Take a look at it together. I've never dealt with a Raspberry Pi Pico. Need a knife. Alright. Got a USB cable, nice because I don't have very many micro USBs left. Everything's USB-C now. We got our GPIO pinout, some stickers for labeling, what we need it for, documentation. Alright, let's check out the board itself. That's pretty cool. It's got Wi-Fi, Bluetooth, everything and more that I could need for the USB keyboard. So it will run the USB keyboard, but as I progress, it might end up running other things like sound effects or light effects or whatever. So yeah, I'm excited. We'll dig into the software side of it here and get it programmed and move on from there. Alright, I'm on the computer now. I need CircuitPython and KMK firmware for this USB retro keyboard to work. So I have pre-downloaded it already, but go to the installing CircuitPython webpage, follow the instructions. We're going to go through them anyways. Click here to download it. It opens up CircuitPython's page. You type in your device. I have the Pico 2W, so it gave me a specific file for that device. And then it says start the UF2 bootloader by double clicking the boot or reset pin. Mine booted up no problem, and I have access to it. So from here, I believe once you get into that bootloader mode and you can see your, it says that it should be called RPI RP2 for all RP2040 boards, but in here it's showing up as RP2350. So I'm assuming it's good, and we're going to try it anyways. To install CircuitPython, grab the file you downloaded and drag that file into the boot drive on your computer. So I said I'm guessing this is the boot drive. We're going to grab this and copy it and paste it in here. Okay. The light should flash. Boot will disappear, and a new drive will show up on your computer called CircuitPy. Let's see if that's happening. Oh, it looks, yep, perfect. I'll have to show that screen here. I'll just add it now that it just popped up. D file explorer. Okay, there it is. All right, so we now have this CircuitPy with all our files on it. So perfect, that's looking good. Go back here. You successfully installed CircuitPython. When you plug in a CircuitPython board into your computer will see the board's flash memory as a USB flash drive where files can be stored. You've successfully installed CircuitPython. You'll see CircuitPy drive. When you double tap the reset button on most boards, you'll see the board name boot drive, or when you hold the boot select and tap reset for RP2040 boards, you will see RPIR2. You can drag files and yes, okay, we've done that. Or when you drag that. All right, so now we need put the KMK firmware, which is called the Clackety keyboard powered by Python. So we'll go through here, features, getting started. KMK requires CircuitPython 8.0 or higher. We just did that. And our getting started guide can be found here. Life was like a box of chocolates. You never know what you're going to get. Okay. Focus layered, sits on top of CircuitPython. Board says support, blah, blah, blah. Install CircuitPython version 7.3 or higher on your board. With most boards, it should be easy as dragging and dropping the firmware onto the drive. Up-to-date copy of KMK from the main branch. Unzip it, copy the KMK folder and the boot Pi file at the root of the USB drive corresponding to your board. Create a new code Pi or main Pi file in the same root directory, same level as boot Pi with example content here under. Important, adapt the GPO GP1 pins to your specific board. So print starting, import board from, okay, keyboard, keyboard, column pins to GPI 0, keyboard row pins to GPI 1. Keyboard diode orientation dot column to row. The wire paper clip, whatever, connect the pins you select for column, pin, and row together. If it prints the letter A for a Q, or depending on your keyboard layout, you're done. Or a Q. Okay. So we're going to get that copy that we need. So we'll go back to the main repository here, download the zip, and then I'll just extract it real quick. All right, so what did it say there? Let's copy the file anyways. I can't remember. It said, well, what is... All right, well, that's new. When I right click and I want to open in a new tab, it's not letting me. Okay, whatever. Up-to-date copy, unzip it, copy the KMK folder and the boot Pi file. Okay, so we're just gonna take this into our CircuitPy and I believe just go up. Yeah, just drop it right in here, paste. Okay, we'll let that do its thing. So we need a new code Pi or main Pi file in the same root directory, same level as boot Pi. Adapt the GPIO pins to your specific board. So we will go to Visual Code. Let me add Visual Code into OBS here. Alright, so we're gonna go File, New, Text File. Paste that code in. Oh, that's not the code. This is the code. Paste this. And then save it as What did it want again? Main? Code or main? We'll go with code. Whoops. Code, I guess. Shoot, where was I? Visual Studio. Code Pi. And we will just save that in documents. Sure, that's fine for now. Okay. We've done that. So that needs to go into the root directory. Same level as boot pi. So we'll let this finish transferring here. It's not quite done yet. Where are we at? 84%, just about. All right, that has been transferred. And then we will transfer the main Pi code there that I put in documents. So we're going to copy and paste here. So firmware, so it's got to be in the same root level as boot pi, so we're just going to paste it here. And that's it. Now with the wire and a paper clip, whatever, connect the pins you selected for column pin and row pin together. So our column pin is 0 and our row pin is 1. And we should just let me get a jumper here and we'll see if we can't get it to print something. All right, so I figured it out. This code pi needs to be changed to my specific code. So this is the base that it gives you, and then from there you need to build off of that. And I have built this up. I used a little bit of help from ChatGTP because I didn't feel like sitting here writing all this code and figuring it all out. So I gave it my key map matrix and just told it to give me the Python for it. And yeah, we'll save this into the CircuitPy and overwrite that code pi exists, replace it. All right, so from there, I believe that it should work. So, okay, large define key map. Key map contains the flatless keys. We've done all the key mapping. Should act as a keyboard now, so let's unplug it and plug it back in and see if it shows up as a keyboard. Doesn't. It just opens up as CircuitPy. All right, gonna deep dive into it a little bit more. All right, I got everything working. I used it's a little bit to figure out. There's quite a bit of coding and key combinations for your mapping, your matrix mapping. Can be a little intimidating. If you do get stuck, there is help like ChatGTP or Grok or whatever the other ones are. I can't remember them all. But this is my main Pi for the TRS-80 keyboard. So if you had the same keyboard, this is your mapping. You could literally copy this and throw it into your setup. This is my boot. So when it boots, it goes through this sequence first. I have it set to short out GPIO pin 15 and ground. if I plug it in, and that will bring up the file system. You can change your manufacturer and have an ID so it shows up as like an actual manufacturer keyboard. I don't know what, I had this set to Brent-Tec, but it must have defaulted back. But yeah, everything's working. If I go to a text editor and I short out, so pin 0 and pin 8 will give me an A. Whoops. Hit a couple extra pins there, so pin 0, pin 8. So A, B, 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 right? So I'm just hitting different pins and it's giving me keystrokes, which is perfect. That's exactly what I want. So I'm gonna dive into desoldering the connector off the motherboard and getting it actually wired to be a standalone keyboard. Okie dokie. Got programming figured out on the Pico W2. It's all good to go. I have taken a screenshot of my what GPIO pin and what ribbon it goes to. It's really easy now. Hard part, I need to get this off of here and use these pins and figure out which one of these pins corresponds to the ribbon cable. So that's what I'm going to focus on right now. I am out of wicking, so I'm going to give the old solder pump a try here and see what we can make happen. And perfect. That is amazing. So I got what I needed. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 pins, 16 pin cable. Now the fun part. So I just got paint marker all over me. And I don't know where my rubbing alcohol is at the moment. So I guess we'll just leave the paint marker. Alright. So I wonder if I can use these. Should be able to. Let's grab an X-Acto knife. Even this will work. Alright, so I'm gonna actually label this pin connector with the GPIO pins. I need some alcohol to wipe it down first, so I will be right back. Alright, got the alcohol. Always use 99%. You don't want water. Water's not good. Clean my hands first. And then do this. A good wipe down. So the deck will stick. Okay. So that's the back. So this is going to be 0, 1, 2, 3, 2, 3, but right. But we're not using number 3. Number 3 is dead. So ribbon 1 will be 0. Alright, that'll avoid any confusion. Now we need to turn this down a bit. Maybe like 600. And I need some wire. I wish I had 15 different colors of wire, but that is not going to be a possibility. But what I do have is lots of this. So I'm just going to alternate red, black, and orange just so it looks cool. No other reason than that. Alright. Have the day you deserve. I don't know why that was in there. So we're gonna need shrink tube. I like to keep it black, but yeah, I mean green's gonna suit the theme as long as it shrinks down properly. This, that's bigger. Shit, might go with yellow. Yeah, yellow will work. And red. Red might work. Yeah, we can alternate. Yellow and red, yellow, red, yellow, red. That'll work. Alright. So I'm just gonna prep some of these. I don't need them very long, so yeah, about something like that. 2, 4, 6. 12. I'll figure out what I need from there. So, okay. Don't really need this to be very long because I'll probably end up making some sort of mount so all this sits back here. So really I can keep these wires pretty short. I'll leave a little bit of length just to play with, but yeah, something like that. Alright, we got a completed harness. So we got 0, going to 0, 1 going to 1. Oh, I see what I did there. Actually didn't do that correct. That should still be a 2. Right. I'm going to correct that quick here. So we'll get rid of 15. Okay, that's better. So now that is the GPI open. So 0 to 14 should be easy to trace with the color combinations. So, right, if I'm on the third red from the bottom, oh, I did do that. Okay, everything should be correct now. So said if I wanted the third red, it should be 12. Follow it up. Third red, 12. The sixth red should be 9. Follow it up. Sixth red. It's 10. Oh, no, it is 9. Right. Yeah, so should be able to plug this into here. So, clip, oh yeah, nice tight fit. And we will take this over to the main unit. Plug. Alright, a lot of fiddling around with programming and debugging and whatnot. I got the keyboard working. Alright, awesome. So it's now a USB keyboard, but I have an issue where my membrane is sticking and causing problems, so I need to take it apart again, clean it really good, clean everything, and put it all back together, and hopefully it works properly after that.